Hello, everyone, and welcome back. Thank you so much for being part of the Hope 2020 conference and helping to make this virtual version such a success. We really could not do this without you. So for our next talk, we'll be covering ProjectMF 2.0 with Npstn, brought to you by Cruz, a 17-year-old phone freak from sunny Florida who's been interested in telephones for a very long time, and they've been around for much longer. He's particularly interested in the U.S. public telephone network of the 1970s and 1980s. So after we get through with Dylan's presentation, we'll be doing a live QA session with him. So while we're doing the presentation, please submit your questions to the Matrix chat. We'll be curating them and then feeding Dylan so that he can answer them with you. And with that, I think we're almost ready to go for the presentation.
Mm-hmm.
All right, off to you, Dylan.
So my name is Dylan. I'm a phone freak. I'm 17, right over here in Castleberry, Florida. And today I'm going to be doing a talk on Npstn. I was supposed to mainly focus everything on ProjectMF 2.0, but unfortunately, my friend Michael, he recently caught the virus and he fell ill, and we were unable to finish the main source code for ProjectMF 2.0. So I was going to kind of shift directions a bit and talk a little bit about Npstn and how ProjectMF 2.0 will hopefully soon incorporate on top of Npstn. So right here on my screen here, I have this is a user control panel for Npstn. So members, they have an auth key for this web page here. But first, I'm going to describe what Npstn actually is. So Npstn is a peer-to-peer VoIP network, and it allows collectors and phone freaks and enthusiasts to actually connect their switching equipment and all their telephones to each other in a seamless manner. And we support a wide range of signaling protocols that were widely used in the Bell system, and a lot of other countries like Russia and stuff still use them, like mainly MF signaling and SF signaling. One thing we're actually working on now is we're working on an identifier tone detection system. So step-by-step switches, they know when to send their MF digits over. So first, let's see here. Let me go over here. Here is the member list for Npstn. It's a publicly accessible list of all the numbers on Npstn with their descriptions. As you can see, the wide range of numbers are by Naveen. He's great. He has a lot of stuff here. But here, I wanted to demonstrate a step switch that we have on Npstn. So here, let's see. I think, yeah, here we go. So here we have, this was just put on Npstn, I want to say a few weeks ago. It's the 869 office code. So as you can see here, we have a step-by-step dial tone. So this should be a DISA into that switch. So I have my microsip here. Now I mainly use Linux actually. I actually run Ubuntu 16.04 on my laptop, but I'm still at work. So I have, this is my workstation here. So let me go over here. Let's tell 91 will give us an outside line, in this case for Npstn. This is a simulated step-by-step dial tone, so let's dial this number here, 8201. So here we have a step-by-step dial tone. Let me make this real quick. There we go, that shouldn't remove any echo. So let's dial 8311. That was 2 8s actually. It's not what it was supposed to do. This is actually a wrong number. Let's see what it does. Ringing. You can also hear an off-hook tone in the background if you listen. I don't know if that'll make it over the stream, but there's actually an off-hook tone bleeding on top of the ringing there. That's quite neat. And we also have, here's a 7A announcement machine. It's electromechanical. It has a drum, and it has this little rotating head, and it goes around. Here, let's get 1. Let's see here, 8391. This is direct.
All circuits are busy now.
Okay. But it didn't let us dial it directly. I guess we'll just dial it on top of the dial tone here. Oh, okay. To hang up on us. He's still working on the switch. Let's see. Let's try this one more time. Let's actually try this busy one here. This is 839. So there's a busy tone. Oh, okay, actually, I already tried doing it. Let's try that again. What was it? 01. Okay, now I think it's going to work.
We're sorry, you have reached a number that has been disconnected or is no longer in service. If you feel you have reached this recording in error, please check the number and try your call again.
So that's coming from a Western Electric 7A announcement system. Let's see what else we have on here. Let's see. What's always fun is dialing into switch verification messages. What a switch verification message is usually you'll dial it, and this is still on the PSTN today, mainly in New York City, is you'll dial like the area code, the prefix, and it's usually on 9901. Sometimes it can be on something else, but it will read the location of the switch, the switching equipment type, and all the office codes it serves. So on NPSTN, we do have something similar, as you can see right here. This one is by Sean. 7919901. Let's try that.
Welcome to the NPSTN AUSY01 exchange in Sydney, Australia. This exchange serves code 791. The exchange operator can be reached on 791-0000. This is a recording. 79125. Welcome to the NPSTN AU.
And as I'm making these calls, if I go into the UCP and I click on, let's go white pages, 646-1217, which is what the soft phone is over here. It will actually give us what it looks like it's getting cut off there a tiny bit. It'll actually, what NPSTN does is we have a mock billing system. It'll actually come up with what the charges would be for the calls in the it's based on 1970s rates. So as you can see here are some calls I just made to Matthews, Virginia. That was the 869 numbers I was dialing into that step switch. And here you can see how long the call was and the amount. And here's North Sydney, Australia, and the number I dialed. And let's see, it also has a date and everything here. And then on the side, we have our message units for 1 month, the calls outside the local area, the telegrams, which I'll get into a bit about that in a second. Other charges, we have like a little United States fee, a little directory advertising fee there, service and equipment, $4. Now, now this is based on 1960s and 70s rates, but with inflation, that's actually quite a, well, not quite a bit, but it'd be almost about what you'd pay for a phone bill today. Not really close, but kind of in that ballpark. It's not just $4. Let's see here. So if I go back over here, I want to dial something that actually soups so we can see all the charges here. Let's see. Well, actually, all those 869 numbers, some of those should have souped. The one in Australia did not, though, actually. Let's see here. Let's dial one of Naveen's numbers, actually. So what Naveen's done is he put together on his asterisk system, he wrote tens of thousands of lines of code, simulating various different crossbar and step-by-step systems with immense detail, like real attention to detail. And he got all the sounds from Evan Doorbell and also from recordings of a few telephone museums. And actually he took, I believe, like he took like a summer at Stanford, and they actually had a step-by-step PBX still in operation as of 2018. And as far as I know, it's still in service today at KZSU Studios. And he has a few of those recordings up here, I believe. Let's see here. Then Evan Doorbell has all of his recordings here on NPSTN on the 747 office code. I believe there's like 1,000 recordings here for Evan Doorbell that's directly dialable. Let's find a good number on Naveen's system. Let's see. It's a good one. Well, on the 444 office code is numbers that we've dialed from the FreakNet PrivConf, and we've compiled it into little recordings. So mostly everything here, and you'll find in the 444 office code, is mainly stuff that's usually still dialable on the PSTN today. Let's see, like there's this one number here. This is welcome to GTE Express dial tone. Let's see if this one still works, actually. 1263. I don't know if it will or not.
Welcome to GTE Express dial tone. If you wish to order telephone service, please hang up. Then pick up and dial 483.
So yeah, as you can see, that's still in the, most of everything in 444 is still in service. Let's see. It's finding a good number. Let's see here. Sorry, this is taking so long. Let's see. Oh, he has all Joy Bubble stuff. Revertive pulsing sample. Let's try that one actually. 5510. So as you can see, that was actually revertive pulsing, which a lot of older electromechanical telephone switches actually used to signal each other. It was a very weird signaling protocol. It basically did pulses in this weird, I don't actually understand how the protocol worked, but I know it sounds really cool. And I know if you dial into the Museum of Communications, I believe they have some stuff that uses revertive pulsing. Let's find something that goes on for a bit longer than that. Maybe we'll dial one of his verification messages, which I believe the one on 231 is a play on. Okay, let's see.
Reached the 77th Street Crossbar 1, serving codes 2301. Thank you very much.
So some of you might recognize what that's.
77th Street Crossbar 1, serving codes 231. Thank you very much. You have reached NPSTN NA01 231 234 251 288 355 444 549 650 and 747. Thank you very much.
And then we'll do it again. So what he has there is for each one of his little office codes he has on his asterisk system, they all each have their individual verification announcement. And after that times out, it rings his master verification announcement that lists every one of the office codes on his system. So everything he just listed there are the office codes he currently has on NPSTN, plus and minus a few. One of the cool ones he has is 355 here. Let's see, 355. So here's everything he has in 355. Now each 1,000 block in 355 is supposed to be a recreation of like a big PBX system. See, like right here, it says 355, 3XXX through 8XXX are PBX party lines. Each 100 group is a separate conference. each sub exchange has its own personality. So a lot of stuff on Naveen's system you can actually talk over. There's a lot of intercept messages, and even on busy signals, reorder, ringing, you can actually talk on top of it. And one thing we're currently working on now is with some asterisk patches we developed is to use conf bridges without answer supervision, without answering the call, I mean. So what we can do with that is we can have busy signals and stuff not supervised, but at the same time, we can have it so you can still talk over it, just like on the old network. So let's dial one of Naveen's simulated PBX party lines. Let's see here. Let's see. Let's try 3XXX. Like 3422 or something.
Working number. Please hang up and consult your directory. If further trouble is encountered, please dial the operator. Thank you.
Now, if I grab another phone over here and I dial that same, or a number in there, that block, we should be able to talk over it.
The number you have reached is a non-working number. Please hang up and consult your directory. If further trouble is encountered, please dial the operator.
This is a test talking over the party line. I don't know if you can hear me or not. So that was an example of talking on top or through a PBX party line on Naveen's system. So that really kind of allows you to grasp the feel of the old network, because on the old network, you were never really alone. You know, there was always something in the background, you know, and you could always hear someone else on, you know, another trunk, and a lot of really cool things like that. And that's what we try to recreate on NPSTN, because a lot of people like me, for example, you know, we're really interested in this stuff, but we never actually got to have that experience. We never actually got to experience that on the phone network for ourselves. So we kind of felt left out in a sense, and we wanted to not only preserve the history, but also experience it for ourselves. And the only way we can experience it ourselves is if we can recreate it. So for that reason, it is really cool that Evan Doorbell, that he was able to preserve that much of the old network. I mean, he has just countless hours of various different recordings, and he has his raw tapes where he has like ringing tones that are like uninterrupted, that are like several minutes long, and it's really useful for us because we can go in and we can actually sample that. And obviously, you can't really come close to recreating the old network. There's so much at play, you know, every little thing, you know, it all adds up. And it's really difficult, and we find that it's really difficult to simulate a lot of the equipment on NPSTN. So for that reason, we're trying to find a lot of members who actually have the switching equipment, so we can route calls over it to kind of give NPSTN a more organic nature to it. That's one of the things we're trying to incorporate. So that's why we have like there's several different step switches and crossbar switches on the network. And with ProjectMF 2.0, where that comes into play is there is a sub network on top of NPSTN. We call it StepNet. And there's also NSRT, the Network Service and Route Tandem Network. So what we aim to do with that is connect all these step switches and crossbar switches together and run ProjectMF 2.0 signaling on top of that. So ProjectMF 2.0 will convey all the supervision messages on top of that, because a lot of this equipment is just on, you know, FXO ATAs, and there's no real easy way of retaining answer supervision when you're doing that, especially if every single piece of equipment's different. It gets really complicated. So one method of passing along answer supervision is using an N-band signaling protocol. So what we're currently working on is ProjectMF 2.0 to have at both ends of that connection, so we can actually play a certain tone, you know, if it goes off hook or you know, stuff like that. And the other thing we're doing is we're incorporating that with the NPSTN CoinTall ticketing system, where we have native support for coin phones on NPSTN. I actually did a talk at DEF CON 201 about this, if you guys want to see that. But basically, we can decode coin denomination tones. That's the 1700 and 1200, I believe, tones that are used by a lot of payphones when you deposit a coin. It plays a coin in it plays a tone in reference to the coin you deposit, and we can actually decode that natively on NPSTN. And one thing you can do is let me actually turn this camera over here. It's a little webcam. Here's a payphone I actually have over here. I don't know if I can patch the audio in. Last time I did that, it didn't really come out very well, but we can actually decode the coin tones. And this phone is just connected straight to a regular VoIP ATA. There's no line card here. Actually, I have one right here. Here's actually a payphone line card. This was actually developed by Howard Hart for NPSTN, as you can see here. So technically, we don't need to use these. You have to use a card like this if you want to be able to do collect and return. However, we have native support for coin phones without using line cards or any special equipment. The only downfall of doing that is, like I said, you cannot do collecting, you cannot do return. So what you end up having to do is you have to open up the payphone, you have to put a zip tie on the coin relay to keep it closed. And by doing that, when you deposit a coin, it'll fall straight through the chute into the coin vault, which is right here. It's obviously that's the vault. But so yeah, I mean, it's kind of fun in the fact that you don't have to spend money on expensive equipment in order to use a payphone. But at the same time, ProjectMF 2.0 will support the necessary signaling protocols to send, collect, and return messages to line cards like this. In the future, what we're going to have is you'll have like the line card in between your payphone and your ATA, and there'll be a connection between the line card and something like a Raspberry Pi, and that would be at your end. And what we can do is we can use in-band signaling on the voice call, and the ATA can actually decode that in real time, and based on the information, it can either send the collect and return information over the serial bus to something like this line card here. So that's one thing we're working on. We have some demos of that. I don't have anything I can show you today, unfortunately. That was what Michael was supposed to help me out with, which is unfortunate. But I hope to display something like that soon on the NPSTN blog. Shouldn't be more than like a week or so from now. But shifting gears, I want to also talk about NPSTN telegrams. Sorry if I seem a bit like moving between topics. I didn't really get the time to put together something like a PowerPoint or anything, so I apologize in advance for that. But over here, let's see. We have this tab over here. Let me make this a bit bigger. We have this that's in the way. Oh, okay. Chrome is not, okay, there we go. So here we have the telegrams tab. So here are all the telegrams I have received, and I can send a telegram by clicking on this button here. And let's see, that's my phone number there. Probably gonna have to change that. Let's send this to a friend here. Let's see, okay, telephone number. Let's go 231-1121. Let's put in my number here. Actually, what am I doing? I'm gonna send this to myself, actually. That way I can see the call coming in. So phone number would be 347-5000. But I've never actually tried sending a telegram to myself. So I actually don't know if this will work. It should work though. 612. This is a dummy address. Let's see here. Okay, well, I have this that just came in. Let's answer it.
Hello, this is.
Wait a second. Let's see here. Actually, I don't know what this is. Is this? Oh, actually, I don't know what that is. I don't think that was a telegram. Okay, let's see here. So let's go back over here. Something came up. Let's see, recipient time. What was this at? Oh, it's right here. Well, I guess I did receive it. Let me see if I can get this to go out to someone else. Actually, why don't we just do this by phone here? You can actually send a telegram using, okay, we should have telegrams 117. Okay. I'm getting a lot of spam traffic right now. Let's go here.
Telegrams. Can I have the phone number of the recipient to whom this telegram should be sent?
347-5006.
I'm sorry. I have no record for any subscriber by that number.
Oh, it has to be in the
Would you
directory.
try another number?
347-5000.
Now dictate your message using stop in place of a full stop at the end of each sentence.
This is a test telegram for the Hope 2020 conference. Let's see. Stop.
Would you like a paper copy delivered to the recipient? An additional charge of 50 cents applies.
Yes.
Please make out a payment by cash or check of 50 cents, payable to Dylan Cruz, 701 Sailfish Road, Winter Springs, Florida, 32708. Your telegram order number is
30958.
Again, that's
30958.
Be sure to mention this in the memo line. Once your payment is received, a print copy will be immediately dispatched to the recipient. A telephonic and electronic copy will be dispatched immediately regardless. Okay, give me a minute to send your telegram, please.
And in a moment when it's done sending the telegram over CW, I should actually get a telegram on this phone over here. Let me actually see if I can bring this. I don't know if I can. Here's my Panasonic phone. This is 347-5000 on NPSTN. So over here on this, oh, this is like backwards on the webcam, so it's kind of weird. Here, let me actually.
Your telegram was successfully sent. The recipient should receive it shortly.
Okay, there we go.
Thank you for using Northern Union Cable Services. A charge for this telegram will appear on your bill.
The mock bill.
Goodbye.
So I was going to say over here on this phone, I have CO port number 3 is 347-5000. I can't really go off hook on it just yet because I think the telegram should come in soon. It's on a queue. Let's see. Let's see here. Oh, there's also a TTY relay on here too. Let's see. What's one thing I can demo? We can dial 118 for a StepNet trunk, which is it's currently under progress, under construction. I should rather say. So this will router call through some simulated step and crossbar switches as well as some actual real electromechanical switches. So basically, after we dial 118, we're going to get a dial tone. From there, I'm going to dial a number on NPSTN, and that should traverse the NPSTN StepNet network. Okay, let's see. Let's find a number. I'll dial a number Let me actually turn on my step switch real quick. Okay. So that's dial tone for my step switch across the room. I can't really show it to you, but let me dial 3211 should ring a station. My ringing generator is actually broken. It's supposed to generate a ringback tone. It's supposed to generate a new CDO ring, as I guess what you would call it. But it's only generating the 20 hertz. I still have to fix that. And I'm actually still connected to the switch. Even after it rings, it drops back, so I should be able to dial it again. You hear the ringback tone. If I make the volume a bit louder, you can actually hear the trunk noise, as well as a little bit of feedback that we're still working on. I don't know if you can really hear that very well. Let's try doing 7 should do the same thing. 4 would be a bit loud, so I don't want to call that one. But there we go. Let's see something else here. There's also on Npstn, we have a dial and ring test number, as well as a ringback and ANAC number. So I'll demonstrate those briefly. So 958 should read back the number we're calling from.
646 1217.
And if we dial 959, it should ring us back. There we go, it's coming back in. This is kind of losing the feel for it, since it's not on an actual analog telephone. I wish my webcam, I wish the cord on my webcam was long enough, because I don't know if you guys can see this. You might be able to see that over there, but I have a little homebrew switchboard, which actually me and a few of the Npstn operators, we actually made a skit on the Npstn switchboard. It's called Npstn Operators Committed to Service. I don't know if I could get that to play over here. Maybe we can do that more towards the end. Let's see here. Oh, I can demonstrate the Audicron DSTM. I built an asterisk. So a friend of mine, Alan, from Madhouse Telephone, so what he does is he basically gets these Audicron machines and he restores them. So he sent me, this was about, I want to say maybe back in January, he sent me a zip file of all the audio, of all the actual individual samples from an Audicron STM machine, one that did time as well as temperature, as well as all the advertisements for it. And I was able to successfully recreate that in asterisks with all the samples he sent me. Here, let's see if I can dial into that. It's 3272121 on Npstn. You know what? Let me do something real quick, actually. Let me see if I can actually get into the asterisk console so I can show you guys. You can see the traffic on asterisk and how it's all synchronized. So here's the asterisk console for the system it's running on. You can see right here, let me actually make the text a tiny bit bigger for you guys. Let's see, change settings, appearance, here we go. Let's change this to, I don't know if 22 is gonna be too big. I think that should be a lot better. But as you can see in the background here, that is the DSTM, the digital STM is what that's short for. And as you can see here, it is actually playing all of the samples in the background. So if I were to dial this, it should be in synchronization with what's coming up here on the asterisk console. So let's kind of put this a little bit side by side here. Let's change audio. This is a time and temperature for Orlando.
Trouble on your line? Dial 611 for repair service on your residence phones. The time is 8:35. Temperature 76. Dial toll calls yourself and
So here you
save,
can see the
especially during
sponsor.
daily discount periods. The time is 8:35.
8:35.
Temperature 76.
Then it has a temperature. And then right here, it's waiting 2.31300
Calling long
seconds.
distance? Make a list of what you want to talk about.
see
You'll save more in less time.
Right here,
The time is 8:35.
there is a variable that
Temperature
steps
76.
up and down. It steps up from, I believe it's 1 to 5, and then it
When you
drops back
call
down to
friends,
1
give
every
them a
time.
chance to answer. Let the phone ring at least 10 times.
See right
The
here,
time is 8:36.
there's too much traffic.
Temperature 76.
But what that does is every time it loops, it changes
Trouble
that
on your
variable.
line? Dial
and that's what,
611 for repair service on your residence phone.
that's what actually selects
time
the
is
advertisement.
36. Temperature 76.
And like many things on NPSTN, this is talkable over. If I were to
Dial
dial
toll
it.
calls yourself and save, especially during daily discount periods. The time is 8:36.
It'll answer right when that one
76.
restarts. There you
Calling
go.
long distance? Make a list of what you want to talk about. You'll
Testing.
save more in less time. The time is 8:36.
I'm talking
over
time
a time and temperature line right now.
When you call friends, give them a chance to answer. Let the phone ring.
So that's the Audicron DSTM. A part in the packet loss on this computer, I actually did something quite funny. So I'm about like 500 feet away from the router that's downstairs, and I needed to get telephone service in this room. So what I ended up doing is I didn't feel like running a line all the way from downstairs where or on the side of the house where the NIT is, all the way to up here. So I just went in the attic and I actually spliced a connection in between that cable, and I used 2 pairs out of it. So I'm actually only on like 100 megabit link on here, but with all the telephone traffic I'm running through, I believe in some way it degrades my Ethernet service that's also running through there. So I get like very terrible latency on this connection. So that's why I get a lot of packet loss on the soft phone, for example. But I do actually have a separate connection that goes to an ATA that's downstairs, and that is running over that other pair, which is going to this phone here. So this phone doesn't get relatively any packet loss, although I can't really couple that easily over here. Let's see here. Let me go back over here. There's also, well, okay, let's see.
This is an intercept from AV Productions. If you want to join the conference line, there's a couple of people in here already. It's 324-2663.
Oh, cool. Here we go. Yeah, let's bring that in here. Hello, guys. Hello.
Yeah, we had a couple people in there.
Cool.
It's a party.
Here, actually, let me do something real quick. I just remembered something real quick. Go. There's, okay, let's see here. Where's it at? I think over here. One thing I wanted to talk about just real quick, and then we can pop back into that conference, is 311. It's a party line intercept. Here, let me see if I can pull this up real quick. Looks like I'm actually getting a phone call. Let's see. So what this is this is a recreation of 311, which Evan Doorbell did a lot of recordings about where he lived in New York. And what it is if you can hear softly in the background, there's actually an intercept message that's playing continuously onto the trunk, and it's looped. So when you dial 311 and you join into that conference, you actually have this intercept announcer that's in the background. So other people can dial into it and you can talk on top of the intercept message. Here, I'll join it just real quick on here. As you can hear, it uses some of the, a lot of similar sounds to the one that Evan Doorbell grew up with. So if I hang up from here, put that back on. Here we actually get all the sounds. Okay. I just wanted to demonstrate two more things on NPSTN. One of them is, okay, let me actually go over here. Let's see. One of them is I was going to demonstrate the operator system. I'm getting a call. Sorry about that. I should have been more prepared about that. Let's see here. I wanted to demonstrate the operator system on NPSTN. Although all the operators are currently busy, I just checked with them before the conference. Getting a lot of calls right now. I think some people are dialing into it. I shared my number on the talk earlier. Stupid Google Chrome actually auto-filled it. Okay, well, you know, what can you do? Okay, let's see here. I mean, I guess that's basically it. I wasn't really okay. I wasn't really prepared because just work has been really crazy. I just got hired on as a subcontractor for AT&T, and everything's really just been quite crazy, you know, with COVID and everything. I really wanted to put together this really awesome talk, and I was starting to do stuff in WordPress, but I really couldn't focus on it. But this talk was supposed to be a little bit more involved, and I was going to have a little bit more like video backgrounds and stuff. And I don't know, but I mean, you know, it is what it is, you know, you can't really do anything about that, but I guess I'm ready to. Was supposed to be a little bit more involved, and I was going to have a little bit more like video backgrounds and stuff. And I don't know, but I mean, you know, it is what it is, you know, you can't really do anything about that, but I guess I'm ready to. Was supposed to be a little bit more involved, and I was going to have a little bit more like video backgrounds and stuff. And I think I'm getting some echo here.
Well, that was a fantastic talk, Dylan. Really incredible stuff. You know, it's so great to see renewed interest among younger members of our community in our analog roots. So kudos to you and all the team that was involved in this. And so maybe you could tell us a little about what got you started in phreaking in the first place.
Okay. Well, first, actually, there was a little bit of an echo. I think it's gone now. Let me think. This goes way back. I think the first time I played with the phone, I want to say I was 5 years old, and I was at my cousin's house, and the telephone at my cousin's house, it fascinated me because it sounded different than the one we had here at our house. Like I would pick up the phone and I would wait for the dial tone to time out, and it's like the intercept message, like everything just sounded different to me. And that really kind of piqued my curiosity in this because I've always been one to mess with electronics. And there's just something about that where you have this whole vast network and every part of it is a tiny bit different, you know, than the other part. Nothing's exactly the same. And that used to be more so, getting a lot of spam calls. That used to be more so in the 1960s and 1970s when you had all this electromechanical equipment. But it's also still true today, even with all this digital equipment. Everything is different. You know, everything's programmed by a different switchman. You know, every company has their own set of standards and policies. And I'm gonna have to change my phone number. But I guess what actually got me into the phone was because of that, was because of how different everything sounded to me when I would try to compare things. And I'm just going to leave the phone off the hook.
I would guess that the amount of phone calls you're getting means that your talk has been very well received among the audience.
Yeah, there you go. I'm going to have to call Ma Bell and get my phone number changed. I didn't really like my phone number anyways. It was like 1131. It was kind of weird sounding. So, hopefully I can get a cooler sounding number. But so after I was 5 and I had that little kind of interest in phones, it kind of stopped for a while. I never really picked up my interest in phones until I was 12, and I was at a thrift store. We were getting, I forget exactly why we're at a thrift store, but I was walking there and I saw this 2500 set, right? And I looked at it and I was like, that's really interesting. I want to know how that works, So I ended up begging my mom to get it for me. It was like a $10 or $15 thing or something. And after I brought it home and, connected it and it worked, like it was really cool. And then I saw, I kind of want to make this more custom. I kind of want to do something special to this. So that's when I first got my first VoIP ATA with CallCentric. And it took me a while to get to the point where I was able to actually create stuff on asterisks.
So
but
how old were you when you got your first phone?
My first landline telephone, I was 12.
Excellent.
And then I was messing with CallCentric. And then when I want to say when I was about maybe 15 is when I got my asterisk system running. And I just loved all the customability I had. It took my two passions. It took my newfound telephone passion and my programming passion, and even a little bit of my electronics passion because I get to wire it. And it just combined all those together. And it was like this awesome thing, it was like the stars were colliding. It was like, that was perfect. And then a few years later, I got into peer-to-peer systems. And how Npstn works is we use what's called the CRTC, the Central Route Table Controller, and it runs on top of PHP. It's a publicly accessible API, and you send it GET requests. So we have this central route table, which is basically just a MariaDB database where it has everyone's office code, their name, zip code, email address, all their switch details like their host name, their username, password, all that stuff is stored in that database. So when you send a GET request for something like 5551212, it'll look up 5551 in the database and it will return the URI that asterisk will actually send out, typically using the dial function. And then that's what connects the call. But on top of doing that, we also incorporate logging functions that we use for the billing and a lot of other stuff, which all that can be, it's customizable. If you don't want a certain feature, you can just set a flag in the API. Like if you don't want billing or you don't want NSRT or whatever you don't want, it's fully customizable per your system, which is really nice,
Excellent.
And one of the other things is we want to be more decentralized. So currently what we're working on is what's called the DRTC, the distributed route table controller. What that is we still have a main central route table, right? But what happens is whenever you make a call on the network, it'll download a local copy to your asterisk system. So then the next time you make a call, it will look up to see if there's a record. And if there's not a record, then it will request a record. That way, even if our system is offline, you can still make phone calls just as if it was online. And it allows you to make phone calls more securely and privately because it never passes through our system to begin with, because you have that local information.
You're passionate about it. I'm so sorry we have to wrap it up here. We're right at the top of the hour. But on behalf of all the HOPE attendees, your fellow presenters and volunteers, thank you so much for your talk, Dylan. It was an amazing trip back in time for those of us who remember the publicly switched telephone network. And a big thanks to all the work you and the others have done to make this experience available for other people to enjoy. So kudos to you. You know, in the Matrix chat, you continue to interact with the people who may have questions, answer the questions for them. And I'm sure there's some people who want to contact with you to figure out how they can be involved in this or learn from you.
Thank you.
So join us for our next talk at 9 o'clock on how Asian makers unite during the COVID-19 crisis. Again, thank you.